Really quickly, dynamics. Dynamics starts off with Newton's laws. Here's a wonderful picture of Newton. Don't worry, you don't have to know what he looks like. But we have three of Newton's laws. First law, law of inertia. What is inertia? Inertia is like mass. It says an object at rest will stay at rest. An object in motion stays in motion in a straight line until the net force acts upon it. What does that mean? That means if I have two objects and one is 10 kilograms, another one is 5 kilograms, which one has more inertia? Easy, the 10 kilogram one. Regents tries to trick you. They say this guy is maybe going at 20 meters per second and this guy's going at 2 meters per second. Now, which one has the more inertia? Still this one, because inertia is mass. It's not asking momentum. If it was, momentum is mass times velocity. But if it's only asking inertia, it's just the heavier object. That's all that matters. Sorry, not heavier, the more massive object. That's all that matters. And what this also means is that if I have a car and it's going at a constant speed, constant velocity, then it must be in equilibrium, and it doesn't have to have an F net. F net equals 0, because A equals 0. So objects in motion will just stay in motion, doesn't need a force if it's going in a straight line. Needs a force to go in a circle, needs a force to speed up, needs a force to slow down. But if it's going at a constant speed, then either there's no force at all or the forces cancel out, there's no net force. Second law is just F net equals ma. Just remember these guys are vectors. So I mean, if I have an applied force and I have a friction force, you're going to have to subtract those two because it's F net equals ma. Newton's third law is action-reaction. Forces always exist in pairs on two separate objects. For every action, Newton meant force, there's an equal and opposite reaction. What does that mean? Well, that means that if the hammer hits the nail, right, with a certain amount of force, that hammer's gonna feel the same force backwards. Notice one force is on the nail, it's supposed to be a nail, and the other force is on the hammer. Or if we're thinking about the law of gravitation, doesn't matter that one mass is greater than the other, right? Each one is going to experience GMM over R squared, or in other words, they're both going to feel exactly the same force. Look on the table, right? It's the earth pulls the book pulls the center of the earth. That's the action-reaction pair. Same thing with electrostatic forces. If I have a positive and negative, they both pull each other with Fe equals K Q1 Q2 over R squared. So you need two objects to create a force. There's a video I saw recently, I don't know, I think it's probably AI generated, but the astronaut's in the middle of the room in the space station and he's spinning around and he can't move. No matter how much he spins and twists and consorts, he's kind of stuck in the middle because there's nothing for him to really push off of. I don't know if that was a true video, but the idea is true, that you need two objects to create a force.